want to do a proof by mathematical induction for you. So we're always going to start by trying to just prove S1. So I'm going to take the first term, which right here is 1 times 2. And if I put in n equals 1, hopefully this is true. So 1 times 1 plus 1 times 1 plus 2 equals 3. So this should equal 2. And let's see here. That's 1. I don't care about that. That's 2 times 3 over 3. We can see that equals. Okay. Then we're going to rewrite this in terms of k. So 1 times 2 plus 2 times 3, so on and so forth to n times n plus 1. But now we're changing it to k's. I said k and then I didn't do it. K equals k plus 1, k plus 2 over 3. Okay? Then, if this is true, the next step, k plus 1, should be 1 times 2 plus all the way to our k plus 1. And then the next term should be k plus 1 times, well, then that's going to be k plus 1 plus 1. Okay? So that should be our next term. And that should equal, well, k plus 1, then k plus 1 plus 1, and then k plus 1 plus 2 all over 3. So I'm just replacing n with k and then k with k plus 1. So when I clean this up, I have s of k plus 1 equals 1 times 2, so on and so forth, to k plus 1, k plus 2, and I'm saying that should equal k plus 1 times k plus 2 times k plus 3 over 3. Okay, saying that logically that should be my next step. So now, can I prove that? So what I'm going to do is I'm going to take my original one, this one right here, okay, but I'm in terms of k, so here. Okay, so I'm taking that first step. So I have k plus 1 times k plus 2 over 3. Okay, so this was my original answer here. Okay, and I'm going to add my next term, what I say my next term should be. Okay, and I've got it simplified down here, so I'm going to use this one. So k plus 1, k plus 2. I'm saying that should be my next term, and I say I should get this. So then, do I? So I'm just adding it. So let's see here. I need a 3 and a 3, right? And then I'm going to factor out. So then I've got k plus 1, k plus 2, plus 3, k plus 1, k plus 2, all over 3, because I've made a common denominator. Then I'm going to factor. So let's see here. I have a k plus 1. It's gone, gone. And I have a k plus 2. Gone and gone. What do I have left? I have a k. I have a 3. All over 3. And I just proved it because that is what I said I should get. Okay? So all we're really doing is we're saying, okay, well, logically following this should be the next step. If I go back to my original one, what I started with, and I add the next term to both sides, do I get what I said I should get? It's just kind of a logic train. Does the logic pan out? And that's what I'm following through on.